Hey guys, Mr. Wilson here. Today we're going to start our third unit of parallel lines, properties of parallel lines. And this is one of the more difficult sections of the first chapter, so make sure you're tuned in, make sure you got the closed captioned on, but better than that, you have your earbuds in and you're listening and paying attention as you're going through this lesson. Alright, at the end of this video, you should be able to identify the three types of angle pairs formed by a transversal, and you should be able to use angle properties of parallel lines to find missing angle measures. Okay, we'll start off with some vocabulary. Okay, first of all, a transversal is a line that intersects two or more coplanar lines. Transversal. Okay, in this diagram here, we have a line that intersects L and M. That line is T. Line T is the transversal. It intersects two coplanar lines. Okay, from this, there are three types of angle pairs formed. Okay, and we're going to talk about those angle pairs, making sure that we can identify them, and then later on in this lesson we're going to talk about what's special about them in the case that our lines are parallel. But before we talk about parallel lines, let's just make sure that we are able to identify the three types of angles. Okay, so we have alternate interior angles. In the diagram above, which angles are considered interior? So interior inside the two non-transversal lines. So here we have T as the transversal. Interior, transversal has to intersect two lines. So if we take these two lines, the angles on the inside are interior angles. So you see that 1, 3, 2, 4. They're all inside these two lines. So which two lines which angles are considered interior? Angle 1. I'll just do this in numerical order. Angle 2, angle 3, and angle 4. All four of those angles are inside line L and M. Okay, so now looking at the name, it says alternate interior angles. Okay, so which angles are considered alternate interior? So that means they're inside. This is a pair of angles. They're inside and on different sides. So angle 1 and 2. Okay, notice that they are both inside and they're on opposite sides of the transversal. One's on the left, two's on the right. And angle 3 and 4. Inside on opposite sides of that transversal. Okay, notice how these pairs are on alternate sides of the transversal, if I didn't say that enough times already. And that is why they are called alternate interior angles. Alternate sides of the transversal inside the two lines the transversal intersects. Okay, and so staying with creative names, we're going to talk about same side interior angles. Okay, guess why they're called same side interior angles? Okay, that's because they're inside interior, the two lines that are intersected by the transversal, and they're on the same side of the transversal. So those angles are angle 1 and angle 4. Those would be considered same side interior angles. And angle 2 and angle 3. Again, same side interior angles. Same side, inside. Okay, notice how these angle pairs are on the same. Sorry, not alternate. The same side of the transversal. Hopefully I'll fix that for you guys. Okay. And the final angle pair is corresponding angles. Okay. Now, corresponding angles, I like to think of them as the angles that are in the same spot for each line in the transversal. So angle 1 and angle 7 are corresponding angles. Because for line L and line T, they're the bottom left. For line T and line M is the bottom left. Okay, so angle 2, if you take a guess at it, well, angle 2 would be matched up with, just triangle it here. Angle 2, top right of T and M, should be matched up with angle 6, top right of T and L. Angle 3 should be matched up with angle 8, angle 4 matched up with angle 5. These are corresponding angles. They correspond. Usually if you think of correspondence, it means they're in the same place, they're working together, or they're the same thing. Okay. Alright. Notice how on all these angle pairs, one of the angles is made by the transversal and the line. While the other angle is made by the transverse. Oh, sorry, I said the line. Line L, while the other angle is made by the transversal and line M. Line M. Ooh. Okay. All right. So let's classify each angle pair from the diagram. We have angle 1 and angle 3. 1 and 3, we have transversal here, two lines that the transversal intersects. 1 and 3 are on the same side and inside. So they are same side interior angles. Five and 6, transversal, two lines. So I see this 5 is in the top left. 6 is in the top left of the second line. Okay? And so angle 5 and 6 are corresponding angles. Angle 1 and 5, what kind of angles are these? These are vertical angles. I know that we didn't just talk about them, but vertical angles are angles that we'll use all the time, and we should be able to identify pretty quickly. Okay, vertical angles, yeah, are going to be important for us. Angle 3 and angle 4, okay, again, transversal two lines. They are on different sides inside the two lines. They are alternate interior angles. And then angle 1 and angle 4, well, together they just make up a straight line. They are supplementary. Okay, so a couple of supplementary flashbacks, not too far back, from last chapter, just talking about vertical angles and supplementary angles, but the same side interior angles, corresponding angles, and alternate interior angles. Okay, nice thing about geometry is that you can't just forget what you learned before. It will come back to help you out. Okay. All right. So we identified angle pairs just to identify them. But when a transversal intersects two parallel lines, something special happens. Special relationships between the angles occur. And so we're going to talk about a couple of the postulates and theorems that go along with these angle pairs when we run into a transversal intersecting parallel lines. So the corresponding angles postulate. If a transversal intersects two parallel lines, then the corresponding angles are congruent. Okay. Since L is parallel to M, in this case we see they're parallel. Remember, that's what these arrows mean on our diagram. Since L is parallel to M, we can conclude that angle 1 is congruent to angle 2. Because if a transversal intersects two parallel lines, then the corresponding angles, 1 and 2 corresponding angles, are congruent. So 1 and 2 are going to be congruent to each other. The alternate interior angles theorem says if a transversal intersects two parallel lines, then alternate interior angles are congruent. Okay, we can see it like equal sign with a squiggly. Okay. And we can just go through a proof just so we can see that we can do that. So in the diagram, it gives us that A is parallel to B. They want us to prove that angle 1 is congruent to angle 3. So they want us to prove that alternate interior angles are congruent. And we can do that with what we know right now. A is parallel to B. Again, that's given to us in the diagram. They told us that with those arrows. Angle 1 is congruent to angle 4. Why can we say that? Well, that's the corresponding angles postulate. Corresponding angles postulate. Okay, that's exactly what the corresponding angles postulate says, that corresponding angles are congruent. Okay, we can say that angle 3 is congruent to angle 4. Why is that? Well, they're vertical angles. And then we can say that angle 1 is congruent to angle 3. And that is the transitive property. Transitive. Okay, because 1 is congruent to 4, 3 is congruent to 4. That means 1 is congruent to 3 by the transitive property. And so now we proved, just by knowing what we already know, and that A was parallel to B, that alternate interior angles have to be congruent all the time. Because that's all the information we got, was that the lines are parallel. Okay, and everything else we just used off of what we know already. Okay, alright, couple more things to get through here. Alright, if you want to take a shot at this, maybe you can, maybe you can't. We'll talk about same side interior angles theorem. If a transversal intersects two parallel lines, then the same side interior angles are supplementary. Remember that supplementary means that it adds up to 180. Okay. And so we're going to prove here that angle 1 plus angle 2 equals 180, or that these two angles are supplementary. So A is parallel to B. How do we know that? They gave it to us. Okay, remember that given can be given to us as like a given statement, or it can be given to us as information in a diagram, like they did with midpoints in the first chapter and last chapter. Alright, angle 1 is congruent to angle 3. Why do we know that? Well, they are corresponding angles. Okay, angle 3 plus angle 2 equals 180. How do we know that? They're supplementary. They make up a linear pair. Okay, call it that when it two angles together make up a straight line. And then angle 1 plus angle 2 is 180. How can we tell that? Well, this is substitution. Substitution. I usually just abbreviate that word. Okay, because we said that, first we said angle 1 is congruent to angle 3. And then we said angle 3 plus angle 2 equals 180. And then what do we do? Well, instead of writing angle 3, we put in angle 1 because we said already that they're the same. So now we've proven that same side interior angles have to be supplementary. So that's all the information we started with, and we were able to prove it. Alright, kind of a technicality of this. Notice how the first property is a postulate while the other two are theorems. The difference is that a theorem is able to be proven to be true, while a postulate isn't. It's just accepted as fact. Okay, so we accept this fact that corresponding angles are going to be congruent. Okay, doesn't change how much we believe in it. We should believe in it the same amount. Alright, so now, knowing what we know about corresponding angles, alternate interior angles, and same side interior angles, let's solve for some variables. You can use this information now. Okay, so starting off, we see that we have parallel lines and some variables here. So we're going to find out how we can use this information to solve for x and y. Follow along with me here. We have parallel lines. I'm going to look for alternate interior angles or same side interior angles and corresponding angles. And I notice first these corresponding angles. I notice that x and 70 are basically in the same position. Okay, these are corresponding angles. So I know that corresponding angles are congruent. So x has to be 70. Right? And then I also know that these three angles together make up a straight line. So 70 plus 50 plus y equals 180. Okay, maybe that's not the best way to do it. But I'm going to say that 120 plus y equals 180. Oops, 180. I had 120 on the mind. I'll subtract 120 from both sides, and then I find that y is 60 degrees. Degrees, so it's 60. Okay, and so I should be able to check, make sure corresponding angles are the same. 70, these add up to 180 because it makes them straight line. Okay, that makes sense. Alright, let's find the value of x for this next problem. We have 15x plus 7 here, and we have 18x minus 14 here. Alright, so what kind of angles are these? Okay, first of all, I need to know that these lines are parallel. They did not tell me that these lines are parallel. Okay, and we cannot solve the problem until we find out that they're parallel. Okay, if they don't tell us that, then we can't solve the problem. But I'm telling you guys now that these are parallel lines. Okay, so those are parallel lines. We have 15x plus 7 equals 18x minus 14. We're going to go ahead and solve this. Get 3x by subtracting 15x from both sides. Add 14 to both sides. 3x equals 21. Divide by 3. X will equal 7. Okay, and so important things, guys. Remember the three angle pairs, corresponding angles, alternate interior angles, and same side interior angles. And then remember that these special relationships happen only when a transversal intersects two parallel lines. It doesn't happen every time there's corresponding angles, but only when the transversal intersects two parallel lines. Alright, we will make sure you study this and look at this. We'll do some more tomorrow. See you.